let me introduce the speaker. Today we have Nandini. She's studying computer science engineering and located in Hyderabad. She likes to work on technologies like Java, front-end technologies like HTML, CSS, and also uses databases very frequently with SQL. Um, I'm talking about structured query language. She is here today to show us how to use Java Cassandra driver.
Good morning, everyone. Today I am going to be explaining how to download and set up your Java Cassandra driver and few basic programs so you can understand how to use it. The prerequisites we need are Cassandra, any version that you can work with, and an IDE. So the Cassandra version that I'm working with is 3.11, and the IDE that I'm using is NetBeans 12.4. So downloading Cassandra is pretty simple. Go to cassandra.apache and click download now, and just select the latest stable version and click this link. So when you click this link, it should download a tar file. So after downloading that and extracting the file, I'll restart my Cassandra. Okay, our shell is activated. Now, the ID that I'm using is NetBeans. So you can go to the official site and download it. This is very simple. Now, since we have everything set up, we'll move on how to download the driver. So go to datastacks.com and downloads and select drivers from the tab. And from the drop down list, select Java driver and click download. So you can see there are a lot of files. Based on your project requirements, you can download the required files. The main file that we need to download is Java driver code. So when you click download, you can see that it gives you a lot of options like jar file, which you can add it to your project. The way I did it is through Maven dependencies, this POM file. I'll show you the dependencies in a second. I also want to mention that all the code I'm going to show is available in my GitHub, Nandini1510. So the dependencies that I added are in download and setup driver folder. Go to dependencies.txt, and you can see this is the XML code that I pasted in my POM XML file of my Maven project. So these dependencies will directly fetch and download the driver for you. This might look a little confusing, so I'll show you how to do it. So open NetBeans and select new project. Open Java with Maven and click next. So you can find your POM file in project files, and you copy paste the code from my GitHub here. Before I do that, I want to show you that the dependencies folder is empty. So let me just copy this. So after saving, you can see that all the jar files are downloaded. So this will download my Java driver, and this is a plugin that ensures that when I'm compiling my jar file, all the added dependencies are included. Now
One
that we
one second, Nandini. Can you go back and do that step again? Because when you started with a new project,
yeah
explain the two steps very slowly and
okay
do that one more time.
yeah So the dependencies that I use is in dependencies.txt file. So this might look confusing. So how you do it is you open your NetBeans, click new project and select Java with Maven, and just select Java application and click next. And you can name it anything and click finish. Now you will find your POM XML file in project files. Open it, and after the properties tag, you will copy paste your dependencies. Now before I do that, I want to show that dependencies folder is empty. So I will copy this from this build tag all the way to dependencies tag, copy it and then paste it here. After pasting, when you save the file, you can see that all the jar files are added.
So at this point, do you need internet connection where it can go and download all these jar files?
Yeah, we need it.
Okay, got it. Cool. Continue.
So these are the dependencies that download my driver. And this is a plugin that ensures when I'm compiling my jar file, it includes all the added dependencies. So now that our driver is downloaded, we'll look at a few simple programs. So we'll go to the simple demos folder. You can see a lot of Java files and one SQL file. Since it's numbered 01, we'll go to that first. So in this, we are creating a key space called Cas demo with the class as simple strategy and replication factor as 3. And then we are creating a table employee and inserting some data into it. So let me show it to you in my command prompt. So using cas demo key space, I already executed all the SQL statements. So I should have a table employee, which I'll show it. So you can see that it has employee ID, first name and last name. Now, after doing this, we'll move on to the next program, which is get cas cluster info. This is a simple program that displays the cluster name and the version we are working with. I will open this project in my IDE. The first class to look at is cas connection manager. Uh, this is a class that will connect us to our database. Since we'll be using this code a lot, it's better to write a separate class for it. So we import all the required libraries. The first one is the DataStax Java driver library. And then we declare a SQL session. Through this session, we'll execute all the queries that we build. So using a method builder, we add contact points. This is my local host and this is my port. And authentication credentials, I specify the data center and the key space that I'm going to be working in. And at the end, I call the method build. So it builds my session. And then this method returns me the build session. And this closes the connection. So in this program, this is our main program. We will import the required libraries. And then using the cas connection manager, we'll connect to the database and get the session. Now to build our query, we use simple statement. It has a method called builder, and we will pass the query as an argument to it in form of a string. And then we call the method build to build the query. Using session, the session that we imported from cas connection manager, we will execute the build query. And the execute method, actually, its return type is a result set, which is a set of rows. We can actually select the row that we want to work with using methods. It has one of the methods called one, which will return the first row in that result set. So using that method, I get the first row. Now to print the fields in that row class provides us with a lot of methods like get string, get int, and get long. So based on the data type of the column, we use those methods. Since I want to print the cluster name and it is a string, I'm using getString method, and I'm passing as an argument to it the name of the column. And I'm doing the same here. The result release version is the column name, and since it is a string, I'm using getString method. And I'm printing the fields that I received. And this is a catch block in case I have any exceptions. Now let me just run it so I can show you the output. So you can see it printed connected to test cluster and it is running 3.11 version. Now we'll look at another program, which is just basic insertion into the table employee that we created. So you can find the program here, read write Cass EMP. So I'll open it here. This is the same class, Cass Connection Manager, which connects to the database. I'm importing the class and getting the session. Now again, using simple statement, I build my query. This is a parameterized query since I didn't specify the values that I'm going to insert. And I also want to mention that all the data will be generated randomly. So the employee ID, the first and last name is generated randomly. So I'm using the employee ID. I'm using Java random class with the method nextInt, and I'm generating the ID. NextInt usually generates a number between 0 and whatever argument that we pass to it. Since I want a number between my minimum and maximum range, I add my minimum at the end. So it ensures I get a number between minimum to max. Now, the first and the last name is generated using UUID class. So it has a method random UUID, and I'm using toString method to get it in the form of a string. So it returns me a string of letters. It returns me a string of letters and numbers separated with dashes. So what I'm doing in this code is I'm replacing the dashes with null characters. I'm doing the same for last name. And you can recall that I did not specify my values here. So to add the compiled values to this query, I'm using add positional values method, and I'm sending the details of the employee as argument. And then I'm calling build method to build my query, and I'm executing it. My next query will be selecting the employee details based on an employee ID. I'm doing the same thing. I'm adding positional values as 1001, and then I'm building the query and executing it. It returns me a row, and I'm printing the details from the row. Since the ID is a int, I'm using getInt method, and for name, first name and last name, I'm using getString. And my last query is selecting the details of the employee of 5 employees, and I'm printing that. So here, when I execute it, I'm receiving it as a result set since it's like 5 rows. and I'm using for each loop to print each row. So then it is done. So when I run this program, you can see that it printed the employee details with ID 1001, and it printed 5 rows. So when you go back and check your employee table here, you can see that previously it had 7 rows and now it has 8 rows since we inserted 1 row. Now that we got a little idea about uh, using the driver to insert into the table and display from it, we'll
One,
look at a more.
one question.
Yeah.
I see you're using that Cas read consistency. I might have missed what is the consistency you set? What is that variable?
I
Read
set
write
it as,
consistency.
yeah,
Okay.
1. Consistency level is just 1.
Okay. Cool.
Since mine is a single node, I just gave it as 1.
No, that is good. I just wanted to see how you declared that
Okay.
consistency.
Okay.
Thank you.
Okay. Now that we have a basic understanding, we'll look at a more complex program. So the next set of programs we are going to look at is in 3.1 Sales app. So generally, whenever we test any code or in any sort of training, we need data. So we can't manually generate this data. We can write programs on it. So this is what these programs are going to do. It will generate random details of a user, product, and orders. So the first thing we do, we go according to the numbering. First 01, 02, then 03. So in 01, we are creating a key space called sales with the following characteristics. And after creating sales, we'll create a few tables. So the first set of tables are lookup tables. These are like we already, these tables help us build our user details and product details. Like for example, lookup email servers has an ID and an email server, and the ID is the primary key. So we have states, the product categories, and user platforms. And then we have user table, which will hold the user information, the product table, which will hold the product information, like the product category, code, description, etc. And our last set of tables are sales order and sales order products. This first table contains order details and the user details of the person who placed the order. And then the last table contains product details of each order. So after creating these tables, we'll insert data into these lookup tables, since these are the base tables that help us build our user information and product information. So in this 03, we are inserting data into each of the lookup tables. Like you can see here, we are adding different email servers, all the states, and the product categories like audio system, gift cards, etc. And user platforms like Android tablet, iPhone, etc. So I will change my key space, which is sales. And you can see the tables I have here are these. Now I'll show you one of the lookup tables so you can get an idea about how it is. So this is my lookup US states. Okay, now we'll look at our first program, which is generating the users. So that will be our generate users program. I will open it in my NetBeans. Before I explain this, I will show you the user table so you can understand how the table is built. So we will have email ID, which is generated randomly, the username and the phone number, which is also generated randomly. The user platform and the states are from our lookup tables that we just created. Okay, the first thing we do is we are reading the number of users that we want to create using a command line, and we are saving it into a local variable. And then we are connecting to the database. Now using prepared statements, we build a query. You can recall that we actually used simple statements in the previous programs. The reason is that we generally use prepared statements when we want a query to run to execute a lot of times, whereas simple statements are used when we want a query to execute once or a very few times. So using prepared statements, I'm preparing my query. My first query is selecting the email servers from our lookup tables. The next is state code from lookup tables, platform from lookup tables. And my last query will be inserting data, the user data into user table. In the for loop, we generate an ID. This ID is generated so we can get the data from the lookup tables. So I'm generating my ID randomly, and I'm binding the ID to the prepared statements, and I'm executing it. And after that, I'm saving my output to a local variable. I'm doing the same with US states and the same with platform. Now in this part of code, I am going to generate the user details. Username is generated using UUID, and the email ID will be the concatenation of username and email server. And the phone number is generated using random class of Java. And at the end, we are binding all the user details to a query and executing it. Before I run this program, I will clear my table. You can see how the program runs. So you can see it's empty. I will run my program. So again, user data is generated. Now, since we have our users, we will generate products. So let me show you the product table. So in this, we'll have product category, which is from our lookup tables. The product code, description, product name, price, and quantity is generated randomly. So same as the user table, we will read the number of arguments, the number of products we want to generate using a command line. And then using prepared statements, I'm preparing my queries. One is getting the category from lookup tables, and the other is inserting data, product information to the product table. And I'm randomly generating the ID and getting the product category from the product table. And here, the product code, name, and description is generated randomly using random UUID method. The price is generated randomly using the random class in Java. And then the quantity is also generated randomly. One thing I want to mention is the decimal data type in Cassandra maps to big decimal in Java, and big int in Cassandra maps to long in Java. And after computing all the values, we will bind it to the insert statement and execute it. So you can see that when we run our program, our table will look something like this. Now, since we have our users and products, the only thing we need to do is the orders. So I'll open that code. So first, I will count the users and the products that I generated. Since I will need the user information and product information, I need to know the range in which I need to generate an ID so I can extract the information from tables. So that is why I'm counting the number of users and the number of products. And then I'm preparing few statements like getting the user details from the table, getting the product details from the table, and then the last three are insertion statements, which inserts into the orders table, the order products table, and the products table. We do the last query so we can update the product quantity. So before I explain any further, I'll show you the the orders table. So this is my orders table. So it has order date, the timestamp, the code, discount percentage, estimated shipping date, etc. These are all generated randomly, and the user details are from our user table. And the other table that I want to show is the order products. This will have the date and the code, and then the product details. You can see that these three orders are same, not three actually. The six orders are same. So that implies that this particular order has six products, and those details can be found here. Now, we will generate the number of orders we want to create using random class, and we will get the user details from our user table, and then save it to local variables. Then we are generating the order details. One thing I want to mention is date in Cassandra maps to local date in Java, and then timestamp maps to instance in Java. So we generate the order, the timestamp, and everything based on those. The code and discount percentage is generated randomly. And then the number of products we want in each order is generated randomly. So in this part of the code, we are retrieving product details and saving it to our local variables. And then this is just the calculation of the order price. And at the end, we are calculating the grand total, which includes our discount percentage. And then we are just binding the order details and inserting them into the order table. And that's it. This concludes my presentation, and I'll be happy to take any questions.
So one question is, while you are generating products, right? You are
Yeah.
telling, say for example, I want to generate 10 products. How did
Mm.
you execute that code? Because you have to pass a parameter.
Yeah. So in NetBeans, you can actually give the command line arguments in this. Go to project properties, and in run, you can specify the arguments that you want to send. So the first argument will be your file name, and this will be my number of products that I want to generate.
So every time you run, you're basically sending that argument of 18 products to generate.
Yes.
Okay, perfect. So one thing I want to mention is, you see how the consistency level is set. That is perfect. Every Cassandra programmer should set the consistency level and
Yeah.
should not leave it to the default settings.
Mm.
Second thing I noticed is you're using that prepared statements, and that is how every Java program or anything which is writing to Cassandra should always use the prepared statements. So that is perfectly written well here. So yeah, this is following all the specifications what Cassandra says. There is one thing I noticed, and probably it is just a education thing. When you are doing generate orders, can you go to that page?
Yeah.
So since Cassandra is a distributed database, right? We don't want to run select count from. So there was one statement where you're running select count.
Yeah, yeah.
Yeah. So what happens is if you try to understand how this is executed on the database side, Cassandra can be running on 3 nodes or 3,000 nodes, right? It is a large database and it is distributed. So what we tell not to do is to run a query which goes across all the servers. Say for example, you have 300 servers, right? Now, with this count, what you're saying is you're sending a query to every single node and saying, hey, tell me how many rows you have. And then it has to come back from all 300 nodes, it will get all the results and combine them to show you the answer. Now, why this is a bad query is because it is going across the cluster, meaning all nodes are involved in this query. And we generally don't do anything which talks to every single node on the cluster. Okay.
Okay.
So that is one reason we don't do the count. But for this example, because this is a sample code you wrote and everything is working perfect, um, we will see how to modify this in future,
Okay.
because we have something called counters. And what we can do, so the idea is basically, I'll just give you the idea. I don't expect you to rewrite the code. The idea is every time you generate a product, you know how many products are being generated. So what we do is we go to the counter table. There will be a counter table which says, okay, I have so many products. You say there is a number 1,000. So the 1,000 products already exist in your database. Now you generated 18 products. So you increment the counter to 18 and you just read the current counter from counter table. You don't even go to the counting. So you don't count the actual original table, you just look at the counters. Okay. So that's a perfect usage of counters in Cassandra. And we try to avoid writing a count function on the tables. But this is perfectly okay. It's a very small education thing. Like if you're writing this on Oracle, it is perfectly okay. But
Okay.
on Cassandra, it's a distributed query which goes to every single node. So yeah, perfect. I like the code. Basically, it is written as expected to the Cassandra standards.
Well, hey, hi, Nandini, Anil here.
Hello.
I mean, that was a great session. I need to go through one more time because Java is completely new for me. But still, my understanding levels were actually good, like with the level of teaching you did. So I just need to go through one more time.
Is there any technical reason why we have to use prepare statement versus a regular SQL
Yeah.
statement?
Uh,
I can
SQL.
I can take that.
Okay.
So basically, even when we are writing code in Oracle, we want to use the bind variables, right? So what happens is when your uh, optimizer basically caches the query without any variables in it. And what it does is the cached query can be easy to execute. So basically, like prepared statement is your cached query. So most of the query plan, everything is cached in the database, and then you just pass variables and keep running that query again and again. So when you have prepared statement versus unprepared, prepared statements are cached, unprepared are not cached.
In Cassandra or any database?
A prepared statement in Cassandra works like a cached statement. In Oracle, it is called bind variables if you want to compare it with Oracle. You know how the optimizer prepares the execution plan and binds it and puts it in cache and all that
Right.
in Oracle. So here, Cassandra does the same thing with the prepared statements.
Okay, because I thought Java, when it sends to the Cassandra, it's just an SQL statement. It will never say, yeah, I'm doing a prepared statement versus a non-prepared statement.
No. If you notice, right, this session.prepare is what telling Cassandra that this is a prepared statement.
Okay.
And then when it is, so for example, if you put this program in loop for 10,000 times, that statement is already prepared on the server side. All it is doing is sending new parameters and running the same query again and again with the new parameters.
Okay, even though it's in a different session.
Correct.
Okay.
Correct, because it's a cached query, and I can actually show you where you will see that cached query. So, do we have any other questions? I have one question, Nandini. So, tell us a little bit more about yourself. What are you doing, and why you are interested in Java?
Um, I'm actually in BTech second year. I'm doing computer science. Interested in Java because it's a pretty easy language when you compare it with C. Since I started my computer language learning from C, so Java is relatively easy. So I like to program with it a lot. And it doesn't have pointers, so I find it easy.
And what are the other programming languages and other software you have interacted with during your learning?
I actually am pretty good in Python and MySQL and even Cassandra a little. And I have a little basics of PHP and HTML and CSS.
Uh, you are a powerful package.
Thank you.
So you are studying or you are doing job?
I'm studying
In which?
engineering second year.
So very nice. Okay. Second year student done this much hard work means really great.
Thank you.
Yeah, Nandini, this was a wonderful presentation, and this is very good work. We definitely will find some other ways to keep you busy, and we already have some ideas on how to keep you busy.
Thank you everyone for taking the time to listen to my presentation.
Yeah, thank you so much even for the session. It is wonderful. Thanks. Yep.
Thank you so much, Nandi. It is a wonderful session.
You're welcome.
Good, Nandini. In the way you differentiated between the connections and the programs that you wrote is really nice.
One thing I want to point out, like, and I don't know if you noticed, all of you, right? When Nandini was explaining between big decimal and decimal, so Cassandra is written in Java. Okay, so all the data types in Java are available in Cassandra. It's just called mapping. So what they do is internally, they just say, okay, you're giving me a decimal. What does it map to in Java? And she mentioned or pointed out that mapping. So a lot of us who work on Cassandra, if you agree with me, we don't know about that mapping. So if you look at that, we have that Prometheus Grafana dashboard, and I'm just showing you screenshots because my actual dashboard is down right now. If you look at one of these sections, we have the prepared statements written down here. So if you look at this image, you see how it tells us how many cached statements are there, how many executed from that cache, or how many total executed statements. And then how do I scroll? Let me open this in a new tab. Okay, here this better view. So you can see here prepared statements, how many are cached and how many times those cached statements are executed. And then we have something called unprepared SQL statements. What does that unprepared SQL statements is like somebody comes and submits an ad hoc query, random query, right? And how many times those were executed. And when you compare between the prepared statements and unprepared statements, generally Cassandra administrators, we would like to see that you're using your application is mostly using prepared statements, because that gives you performance. Basically, your query itself is cached, and it gives you a very good performance when it is cached. Also, we have a prepared statement cache parameter. I don't know exact parameter right now, but you can look at the Cassandra YAML and you'll find the cache. Usually by default, it is 100 megabytes. You can increase it to allow it to store more statements in cache. And we actually tune that parameter in production. We increase the cache.